Hello. So this is a short video, I hope, for parents to help you to understand Common Core fourth grade multiplication and division, and why we do the crazy things that we do. It's actually not even really Common Core. It preceded Common Core, but Common Core incorporates these methods of solving multiplication and division problems. And they don't really get that hard until you get to fourth grade, because that's when you get into two digits by two digits in multiplication or long division. And we don't do those the same way that you did when you were in school. And I'm going to explain to you why and how to help your child if they happen to get homework they don't understand, which, by the way, they shouldn't. If it's too hard for them to do by themselves, then it shouldn't be homework. And let me know, or the teacher know, if that's the case. It should be something they can do on their own. But in case you're caught and you want to understand it, I'm going to give you a real quick tutorial here on how to deal with it. All right? So first of all, let's talk about problems such as, we'll make it 26 times, let's say, 5. Okay, 26 times 5. Now the way that we always did it in the olden days was we would go 5 times 6 is 30. We'd put a 0 down, carry the 3. Then we'd say 2 times 5 is 10 plus 3, 13, done. Okay, that's how we do it. I'm going to jump to now the 2 by 2, just to remind you how we do it in the olden days. And let's say 35 times 24, 2 by 2, two digit by 2 digit. 4 times 5 we'd say is 20, carry the 2. 3 times 4 is 12, plus 2 is 14. Put a 0 down, and then you go 2 times 5 is 10. Carry the 1. 2 times 3 is 6, plus 1 is 7. And then you add it all up. And, tic-tac-toe, you were done. Here's the thing. It's hard to explain why we go through what we go through. Why does it work like that? And the modern gurus in education want kids to understand what they're doing, not just perform a series of steps. They want them to understand it. And so we're tasked with teaching that. And initially it's kind of seems complicated, but it's not as hard as it might seem. Let me run through doing this the Common Core way, what we call partial products. Let's try to take a look at 35 times 24 again. When you're multiplying this problem, what you're really doing is you're multiplying 4 ones times 5 ones and 4 ones times 30. That's really a 30. When we do our little trick, we kind of skip over that basic fact. And they're not allowed to skip over those basic facts. So we're looking at this as 30, hope you can see it on the screen, 30 plus 5. And this is actually 20 plus 4. Now that's not just Common Core weird stuff, that happens to be the way it is. That's what these numbers are. That's what, in the base 10 number system, that's what they really mean. So what they have to do in using partial products, and they don't have to use that method, but it's how we want them to understand it, is they're going to go, okay, 4 times 5 is actually 20. 4 times 30, this is actually 30, I'll write it over here. So 4 times 30, well, what's that? Well, they've learned that 4 times 3 is 12. All you have to do is add that 0, and you've got 120. So 4 times 30 is 120. Then you got to go over here and say, well, I'm also multiplying 20 times 5. Well, what's 20 times 5? Well, it's 100. So we put down 100. Now we're doing 20 times 30. 20 times 30. That's really what we're doing. So 20 times 30, the easy way to do this, you could do any number of ways, but you do 2 times 3 is 6, and then you can just add those 2 zeros after it, which is 600. And yeah, they do know why we can do that. Now we add it up. So we wind up with the same answer, but now they have a thorough understanding of what they really did. And initially, is that hard? Is it confusing? Yeah, it is, especially when you never learned how to do that. And I had to go through that process as a teacher, all of us do, of understanding it on a deeper level. I think it pays off in the end. Should we be doing it? I'm not going to say, my opinion isn't really that important. What's important is that's what's expected. And it does lead to a deeper understanding of this, so I don't have a problem with it, except for when kids get confused, and that's where we need to step in and help them. And this is mainly for you as parents, though. So let's also take a look at division. What's happening when I divide 6 into, say, 347? Okay? If you do the long division way, you go, well, can't do 6 into 3. I can do 6 into 34. That's 5. 6 times 5 is 30. Take away, you got a 4. Bring down the 7. 6 into 47, that'd be 7. 6 sevens are 42. Take that away, and you've got a remainder of 5. Really fast, really easy. But we don't know why it works that way. Be honest. Unless you do. If you are, you're ahead of me, because I had to really figure this out. Why does this work? How do we know? We're following all these steps, but we don't understand them. They want, in Common Core math, they want them to understand exactly what's going on here. And so they take it, again, from a really in-depth approach and look at it for a full understanding of what's going on. So what we would do, 6 into 347, it's very similar to the partial products and multiplication. 347. We're not going to do any tricks. We're going to look at it and say, well, how many 6s could there be in 347? Well, I know that 6 times 10 is 100. Well, that's not enough. I need this many. So, well, what about 6 times 20? How much is that? Well, that's got to be 120. Sorry, 6 times 10 isn't 100. Not even in Common Core. 6 times 10 is 60. You know, it's quarter to 5. Yeah. So 6 times 10 is 60. 6 times 20 is 120. We're still not getting there. How about 6 times 100? See, this is getting them to think about numbers and really getting a good sense of numbers. What about 6 times 100? Could it be 100 times? No, well, that would be 600. That's way too much. How about, let's see, what if we cut it in half? What about 6 times 50? 6 times 50. Well, that would be 300. Oh, we're on the right track. 300. So let's try that. Let's say we do 50 6s. Let's try 50. That would give us 300. We still have 47 left to find how many 6s are in that. Well, that's easier to do, isn't it? Because they know their basic multiplication facts, or they should. So 6 times what? How many 6s? Well, that would be 6 times 8 makes 48. Oh, that's too much. 6 times 7. So 6 times 7. So I'm going to do 7 6s and 50 6s, and that would be 42. And then you subtract just the same way, and you've got 5 left over. So I know the answer is 57, because that's how many 6s I have figured in that are living in this number. So I'm going to put 57, and my remainder, what was left over, is 5. If that looks a little familiar, it is. Here's why. Guess what's happening when you're doing that? When they're doing that? When you did your basic multiplication, you did the same thing, or division, sorry. You looked and thought, okay, how many 6s in 34? And you figured 5. And then you multiplied. You got 30. And you subtracted. And you got 4 left over. But really what you did, what we do when we do it this way, the easy way, is we're actually saying, I'm looking at 340. Remember? That's a 300. That's a 4. That's 4 tens. That's 340 is really what we're dividing in. And we're thinking how many 6s will fit into 340. and this may get confusing, but you don't need, this is just an explanation. That the kids don't really go this far. I'm just explaining it for those of you who want to understand the connection. If this is 340, I just put a 5 here. Is that 5 ones or 5 tens? It's 5 tens because it's in the tens column. That's actually 50, right? Then I went and multiplied and dropped this down. And now I'm just trying to figure out how many will go into 47, which we're getting to the end of the problem we just did, really quickly. I don't know if that's going to make any sense to you. It really doesn't matter if it does or if it doesn't, but for those of you who are trying to see the connection between standard long division and what we're doing with partial dividends and the way we're dividing now, that might just help to explain what we never really understood what we were doing when we were taught this. We were just taught this is how you do it. These days, we want kids to understand it as much as they can. Will all kids understand this? No. Will all parents understand this? No. But if there is anything that I can do to help to work with either you in helping your child or helping your child with it, I'm always available. Let me know. I hope this has helped. Let me know either way. Thank you.